They're contaminating our drinking water, they're contaminating our farmland, our food, our blood and our babies. I'm talking about forever chemicals, PFAS, per and polyfluoroalkyl substances. That's a group of synthetic chemicals used in many products from non-stick pans to shampoo. I'm journalist Angela Walker, and in this podcast I talk to inspirational people and discuss underreported issues. My guest today is environmental journalist Leana Hosea and co-founder of Watershed Investigations. While you're here, please subscribe and comment if you're watching this on YouTube, or if you're listening, please follow and review this podcast. That will mean it reaches more people.
Leana, welcome.
Hi Angela, how are you?
Very good, thank you. Thank you so much for talking to us today. Now, you've just co-authored a series of reports about PFAS for The Guardian newspaper, and we'll talk about those reports in a minute. But what exactly are PFAS, and how did you first start looking into them?
So PFAS are a class of about 10,000 chemicals, and PFAS is their umbrella name, and a lot of them are toxic. And they're kind of nicknamed forever chemicals because they have, it's one of the strongest bonds in nature. It's the fluorine carbon bond. And this means that they are heat proof, grease proof, waterproof, and they don't break down in the environment. So that's why they kind of stay around forever. And what makes them brilliant, which is all those qualities, which means that it's in all your waterproof clothing, it's in non-stick pans, lots of industrial processes, which, need to have high heat, for example. But that's what also makes it, this indestructible quality is what makes it so bad. And a number of these chemicals have also been proven to be toxic to humans. So they are carcinogenic. They cause, some of them cause cancer, or they probably cause cancer, infertility issues, reproduction issues. They weaken your immune system so that vaccines don't work so well in you. A whole host. The more that the scientists are looking into PFAS, the more problems and health concerns they find about them. And again, it's that forever issue because they build up inside your body, and it takes, it's called bioaccumulation. And that means it will stay in your body and kind of be absorbed. And especially if you keep on being exposed to it in your drinking water, in your food, in like your sofa, which might be sprayed with it, the more that's kind of build up and potentially, cause these health problems.
It's a scary thought, isn't it, that PFAS are in our bloodstream and even found in breast milk. I mean, is there no way that we can protect ourselves from these chemicals?
That is a big question because, yes, it's already everywhere. It's been found in rain on the Tibetan plateau, and they're not producing it over there. But because this stuff, we've been few companies like DuPont and 3M were the inventors, real spearheading the production of this chemical. And they've been producing it since the 1950s. And obviously other, they gave the patent, shared the patent with other companies who've been producing it. So it is everywhere. And like you said, it's even in fetuses because you can pass it. Mothers will pass it through the umbilical cord. So babies will be born with it. So this is why there's a number of things that scientists would like to see. So non-essential uses of PFAS being kind of stopped. This is why you've got this legislation proposal in the European Union to ban those non-essential uses and to ban it for all 10,000 PFAS chemicals, which is why there's this massive lobbying push, which we'll talk about because it was part of our investigation, our new investigation. What they're mainly doing is doing a lot of dilution of water. So, you've got some contaminated water and it's above the levels that are allowed. And the water companies will try and just mix it with cleaner water to bring those levels down. Of course, long term, that's not a great solution. And there are ways like that you can filter some of them out. You can't filter them all out, though. I have a water filter. I do put my tap water through the extra filter, and apparently the carbon filtration is meant to reduce some of the PFAS, but it can't get rid of all of it. There's loads of it out there. But that is one way. In Jersey as well, we can talk about that a bit later as well, because one of the articles was about Jersey, where they have found high levels of PFAS in residents' blood. And there is a scientific panel which is looking at how to reduce those levels. And for example, there is this cholesterol drug that they've there's been a small study which shows it reduces it, or bloodletting. So you can essentially, get rid of your blood and try and get, and then your body will kind of replenish the blood. So, it's really difficult. Once it's out in the environment, it's really difficult to, get rid of it. And then when you have got rid of it, then you have to incinerate it. After maybe you've got this water filtration, special filtration system at the water treatment plant potentially, and then they've got to get rid of that, and you've got to incinerate it above 1,000 degrees, which is very expensive, very energy intensive, which is why the costs of getting rid of it are so high. So people kind of want to start to turn off the tap, but massive pushback from industry to doing that.
I can imagine, and we can talk about that in a minute. You've been investigating the scale of PFAS contamination, and you've plotted that contamination on the Watershed pollution map. Tell us a bit more about your findings and about this. I've had a look. It's like an interactive map, isn't it? Just talk us through that a bit.
Yeah, the map actually has loads of different pollution data sets on there. So everyone is welcome to get on that, or the watershedinvestigations.com site. So what we did as well with a group of European journalists across Europe last year is we kind of got together all of the data available. We focus, of course, in the UK, from water company data, Environment Agency data. We actually went out and tested water rivers and kind of discharge ourselves as well, and had that tested, which was sort of the first time that had kind of been done by individuals. So and then we were able to plot high levels of some of this PFAS contamination, and what we found is that it's absolutely everywhere. So it's all over the UK and it's all over Europe. And we were able to kind of look at, start to kind of narrow that down. And that's what we did a little bit more this time, is where are the hotspots? Because we could look at the concentration levels. So some of the hotspots, and we kind of wrote about this sort of in a top 10 hotspots list, is the AGC Chemicals plant, which manufactures PFAS. And that's up in Thornton, Cleveleys. And we tested the discharge from there, and we found really high levels of the proven carcinogenic PFAS just pouring out into what is meant to be a protected river wire. And then there's other areas like Bentham. So I think the map kind of also helped locals start to look into, why are we on this map? And it's because there's a firefighting foam production factory.
Okay.
Firefighting foams have PFAS in them. And they've been testing a lot of firefighting foam there. So they've got some of the highest levels of PFAS in their groundwater in the country. And kind of our map helped them to start, them and other journalists to start looking at it. So that's what the map is really for people to kind of be able to drill down into their local area, for journalists, academics and scientists, because all this information is sort of like, you've got to work so hard to get it all. It's not presented in a very, user-friendly kind of way. So we just try to collate it all and make it, user-friendly and available to anyone.
It's almost like people don't want you to discover the levels of PFAS in our water and in our blood, and coming out from factory discharges into our protected rivers. So, I mean, I know in one of your articles you mention that the industry is employing tactics like those that were used by the tobacco industry to resist stricter regulation. Tell me a bit more about that.
Yeah, so this is the project that we did this year with our European colleagues, and we called it the Forever Lobbying Project, this cross-border investigation involving 46 journalists and 18 experts, scientists, academics across kind of 16 countries. And we really analyzed all of the kind of lobbying data. We put in took us over a year of putting in loads of requests. We had a big leak as well of documents. And we also looked through all of industries. They put in, basically, when the EU kind of had this legislation proposal to potentially, ban or legislate all PFAS as one class, because they all last kind of forever. Industry kind of put in like an unprecedented amount of responses in the consultation process. So what we were able to do is sort of analyze all of it all together. And what we found is that, there's this large scale coordinated pressure from these multi-billion pound industries, and so many kind of industries, a concerted effort to push back against kind of legislation. And some of the ways that they've done it is industry funded scientific research, so it's not neutral research, and lots of exaggerated claims, all to kind of push back against, and kind of misinformation as well. So this is why we likened it to the tobacco lobbying. And I mean, Professor Gary Fuchs, who's a researcher in corporate harm and commercial kind of determinants of health at the University of Bristol, said that the parallels that have been drawn with big tobacco are compelling, but if anything, it's actually much bigger than the tobacco industry could ever have been able to pull together, this kind of corporate lobbying. Like the sheer number of meetings with politicians and civil servants, he said, has been, extraordinary.
And of course, we have a choice as to whether we smoke, but we don't have a choice as to whether we drink our drinking water, really. So what's the government response to all this then? Because this is hard evidence that you're showing them, isn't it?
To the lobbying allegations, DEFRA spokesman said that the government is committed to protecting the environment from the risks posed by chemicals, and they're currently considering the best approaches for chemical regulation in the UK. And the UK has been very weak around chemical regulations, around regulating PFAS. They got nothing near what's been happening in the United States and what's being proposed in Europe. So they've been very slow, and they say it's sort of pragmatic, but an industry is very pro the UK approach and has been sort of using it to sort of beat Europe with, and say, look, you're just going to isolate yourself. You need to have this more pragmatic approach, like the UK, which, and a lot of, scientists and campaigners will say that the UK approach is slow and weak. What we allow, for example, in our drinking water, I don't want to get too technical, but we allow 100 nanograms per litre of 48 PFAS now in our drinking water. And if we go above that limit, then water companies have to do more to bring it below. But in the United States, under the Biden administration, they passed a level of 4 nanograms.
Wow. Okay.
And they've regulated 7 PFAS, but it's so much lower, so that's just one way. And in Europe, they're looking to regulate all 10,000 PFAS in one go, because they all are very persistent and last forever. It takes a really long time to prove each one of those chemicals is going to be toxic, but we already know that 2 of them are hugely toxic. And that was proven, if you know Dark Waters, the film starring Mark Ruffalo about the American lawyer who brought the first PFAS case. That was the outcome of that legal case. They had a 7-year epidemiological study of hundreds of people's blood. I mean, it's the biggest study ever. And that was the one that linked these 2 PFAS to all the health problems. So, you can't do that for every single chemical. It's just impossible. So that's why Europe said, let's legislate them all together, because the more we find out about them, the more similar they seem to have similar or other toxic properties, or they at least all are persistent and build up in the environment. So or they're all persistent anyway. So let's legislate them all. And the UK is not doing anything about that. What they are doing is they're sort of looking at firefighting foam, which is one of, a major kind of source of PFAS is firefighting foam. So they are kind of investigating whether to restrict PFAS in firefighting foam. And they've said they will set out more detail in due course. And so many scientists are like, this problem is like slapping us in the face. Why are we only just starting? We're still looking at it. Is what the UK government are doing. And meanwhile, the cost of cleanup is just ratcheting up.
Yeah, how can you clean up PFAS then? Because they're so persistent, isn't it?
Actually, so yes, and it's really widespread. So if you take water, for example, water treatment plants were never designed to get rid of these complex chemicals. So they mostly don't. And you get a lot of industrial waste and landfill leachate going straight to water companies. And it doesn't get cleaned. It doesn't get rid of PFAS. So you have all this PFAS coming out of the water treatment plants, straight into rivers, into water sources. It's also, spread on fields in sewage sludge. And so what you'd have to do is you'd have to update all of the treatment plants with special filtration systems, which will reduce the amount of PFAS. And you'd have to, in Antwerp, for example, there's this facility where they're actually washing the soil.
Gosh.
So they're washing hundreds of thousands of tons of soil, and then they're having to get, then you've got this contaminated kind of water. You have to kind of distill out the water, and then you have to burn what's left in 1,000 degrees, kind of incinerator to get rid of it.
Sounds costly.
That's why the cost of cleanup, we investigated that and found that if we don't do anything and we just carry on as is like going to be 1.6 trillion pounds across the UK and Europe. And that's just for a 20-year period. So in the UK, if all emissions remain unrestricted, uncontrolled, it'll reach 9.9 billion pounds a year. And then to clean up the legacy pollution that we already have, that's going to cost 428 million every year.
Gosh.
For a period of 20 years. And that's based on existing cost data. And that's actually quite conservative because it's only going to cover remediating contaminated soil, landfill leachate, and to treat just 5% of drinking water in large supply zones for only 2 of the 10,000 PFAS. And so it's just decontamination costs. It's not all the other potential related socioeconomic or health costs. And it also assumes PFAS emissions are going to stop immediately, which of course they're not going to.
So which types of PFAS do you think we could easily phase out? Like which ones could we do without? What products are they in that we just don't need?
Mm-hmm. So I think it's more like what products do we not need PFAS in? I mean, for example, your non-stick pan is coated with Teflon, which is a PFAS. So, there are alternatives out there. There's ceramic pans, waterproof clothing. Could there be there are kind of other materials now being used. So I think in, consumer everyday products, some products I think are just over-engineered. You don't need, does your pizza box have to be lined with, potentially toxic chemical which lasts forever? I think it gets harder when you get to sort of industrial processes. And this is what industry has been really pushing back on, like green tech, or you really need it. But, other innovate, there's innovations coming up all the time. And, if this is not the first chemical that has been banned. For example, there are those 2 toxic proven chemicals that have already been banned. And unfortunately, a lot of the alternatives are all too similar. So they, completely different alternatives out of the PFAS family do need to be found. But, that's happening all the time. And then, those innovators will then be rewarded with huge profits that they'll come up with. So, and there are now non-PFAS firefighting foams as well. So there are alternatives. And I think if, that European EU ban were to come in, already companies are innovating. So you'd assume that there would be, more innovation.
And as a consumer, I mean, personally, I'd rather cook on something that isn't likely to give me cancer. Do you think that we need, consumers need to be a bit more aware about the risks that, when they're buying a frying pan, hey, well, why don't I go for this ceramic one instead of this one that's got carcinogens in?
I mean, yeah, definitely. People deserve to have the choice to know, that you could, that this could potentially, I think with the pan. So what the manufacturers would say is, oh no, when it's, in use, it's completely fine. And in some ways, that type of PFAS that we use in Teflon nonstick frying pans, a lot of it's a bit like asbestos in the way that it's most toxic when it's being created and when it's being disposed of. When it's being used, it will generally only kind of it has to be kind of like a bit overheated for it to turn into a carcinogenic PFAS. But
still not a risk that.
Might not want that. And yes, I think it would be very much better for public health if you had to label everything, for example, if firms were forced to label what's in their products.
Gosh, it's crazy, isn't it, that we always wait until something is proved to be really, really, really toxic, then we regulate it. We always give everything the benefit of the doubt for a very long time before that happens, don't we? Let's talk about sewage sludge. Why not? You mentioned it earlier. It's like a byproduct of cleaning water, isn't it, that we then use in farming. And you found high levels of PFAS in this kind of fertilizer. Just talk me through that a bit.
I got my results from a home DNA test. To my complete shock, I found 2 half-sisters I never even knew existed. Turns out, the man I grew up thinking was my dad wasn't my dad at all. So I started a podcast called Missing Pieces in PE Life, and it curates stories of people like me, people who find family secrets, people who were switched at birth. Every episode is like a documentary that helps find the missing pieces. Missing Pieces in PE Life, wherever you listen to podcasts.
Yes, it was actually quite hard to get hold of samples of sewage sludge, surprisingly. I didn't break any laws or trespass laws clambering into fields that had just been spread, but we did manage to get a number of samples of sewage sludge. And what this stuff is that obviously our human waste will go into the wastewater treatment plant. And then at the same time, as I kind of mentioned before, there's lots of industrial waste will also go to the water treatment plant, and then landfill leachate, and it all gets mixed up in there. And then, as I said, the treatment plants are not able to kind of filter out PFAS in their processes. And so you end up with, what we found was that all these samples of sewage sludge that we got had levels of the possible carcinogen called PFAS at levels that, you wouldn't be allowed to have on a private allotment. And this is being spread all over our agricultural fields and has been for a long time. So, and then what they found in America, they've proven this as well. And, PFAS is also in pesticides, but also what they found in the US is that, it's been an enormous problem for farmers because PFAS has been in dairy milk, which is unsafe levels, and it's kind of taken up by vegetables, by wheat. So it's a significant way that we can top up the PFAS in our bodies.
Gosh, well, I did contact DEFRA to see if they wanted to put someone forward to join us on the podcast, and they didn't. But they did send me a statement, and they put an Environment Agency spokesperson said, effective regulation in the safety of spreading sludge on land is vital, and we are clear sludge can only be used if it does not impair the quality of soil or surface and groundwater. And then they go on to say they're undertaking a multi-year program to better understand the sources of PFAS. And they also said it's not appropriate to compare PFAS in sewage sludge to the guideline that applies to the concentration in soil allotments, because when they're ploughed into the land, they're significantly diluted. What do you say to that?
Well, there is no official, level in sewage sludge. So they haven't even set a safe or regulatory level in sewage sludge. So there was nothing else for us to compare it with. And, that the fact that they don't even have a level, is again another sign of how slow and behind, and that they're still looking into where the sources are. Well, how come we found a lot of the sources that, this has been a problem that's been going on for, decades in, the US, for example. They could just look in the US and see what's happening there. They don't need to be, reinventing the wheel. The scientific information, the research is all out there. I mean, I think it's, it might be because obviously the cost is huge, and kind of we've had insiders at the Environment Agencies, say that they're really kind of scared at the spiraling cost for just 4 contaminated sites. And the Environment Agency, a report for them has found that there's probably more like 10,200 hotspot sites across the UK. So I suppose if you don't look, you're not going to find it. Or, it's sort of, an idea that they might be kicking this, the can down the road. But yeah, as I've mentioned before, this stuff is building up in the environment. It's building up in our bodies. And so that's why a lot of groups would say, well, better action needs to be taken now.
And how do you feel when we see this kind of, like, at best, complacency, at worst, potential cover-up? Like, you've managed to find the statistics. We know how dangerous and toxic PFAS can be. We don't want them in the water. We don't want them ploughed into our farmland, even if they are being a bit diluted. I mean, how do you feel about the responses that you're seeing to these findings?
I mean, I guess in a way, it's not really surprising when you look at the history, of these types of things. And I always think that they would have carried on completely getting away with us not knowing anything about PFAS if it really wasn't for the lawyer Rob Bilott, whose story, again, is told in the film Dark Waters, where you had this farmer who's allowed DuPont to dump waste on his land and has realized, like, why are my cows getting sick and dying? Why is the river, bubbling and frothing like this? And he managed to get hold of Rob Bilott because Rob's, the lawyer's grandma, lived next door. And Rob, his job was to protect and represent chemical companies. So this is the first time he kind of did a favor for his grandma, crossed over to the other side and actually uncovered the biggest, contamination. Really, it's the pollution of the century. It's these handful of companies have contaminated the entire world. The fact that it's in everybody's blood, rain absolutely everywhere, animals as well, wildlife. It's been found in, it's absolutely pervaded everywhere. And the fact that we would never have even known, it's just cover-up works.
Well,
I
you're
think
giving a lot of credit to him, but also you should take credit as well because you've raised an awful lot of awareness. So thank you for your work on this, because if it wasn't for you and Watershed Investigations in the UK, we would all be in the dark. So thank you. And
thank you. That's
you've got your whole series of articles in the Guardian newspaper, haven't you? So people can find out more about this there, and just tell us a little bit more about how people can find out about your work and find out for themselves, read the figures for themselves.
Yes. Well, all our work that we've been doing over the 2 years that that Watershed Investigations have been in existence, it's all on our website. So the way that we work is we do our investigations and then we publish in the mainstream media, and whoever will take us. And a lot of the time that is the Guardian. So you can see all our work on there, or on the Guardian, as you were saying. There's like 10 articles from recently, just this year, like bloodletting in Jersey, the cost of cleanup, and kind of everything, and also something that we didn't touch on as well is how RAF bases are real hotspots of forever chemicals. And what I find concerning as well is that because the groundwater at RAF bases are very highly contaminated, and that a lot of bases personnel and their families could have been drinking that water. So shout out to anyone who might have questions about water that they may have drunk on their bases. I'd love to kind of find out more about that as well.
Leana, what is it about RAF bases that are making them hotspots for PFAS, do you think?
It's the firefighting foam. They will all have like a burn center, kind of like a training ground. So they set crafts on fire and things, and then you practice putting them out with firefighting foam. And that's been happening since the 50s. So again, PFAS is, firefighting foam is such a kind of a source of it. So
wow, that's really
how it would have soaked into the ground. I mean, we kind of showed that the Cambridge Water, some of their drinking water supplies near Duxford, former RAF base, were contaminated, and people off because of our investigation. Cambridge Water had to take some of the supplies off for some of the local villages who could have been drinking that water. They said that they diluted it, but the water companies only started looking for PFAS in like 2018. They only started testing for it. So before that, we will all have been much more heavily exposed. And those who are living and taking water straight from the hotspots areas, they would be the most exposed.
Gosh, it's really frightening. Thank you so much for coming on the programme. You can read all about Leana's amazing work on the Guardian website and on watershedinvestigation.com. Thank you, Leana.
Thank you so much for having me on.
Thank you. You've been listening to Angela Walker in Conversation. Don't forget to subscribe, like and follow the podcast. That will mean it's recommended to other people. Until next time, goodbye.